All right. Thanks, Gary, for giving me the opportunity to speak about this potential next version of Bitcoin. So who here has heard of these words Taproot or Schnorr, these kind of buzzwords these days? Yeah, so the proposed next version of Bitcoin is going to involve both of these technologies sort of interplaying. And we want to talk about what are these technologies, what's Schnorr, what's Taproot, but also more importantly, how do we use these things? Why is it important that a Bitcoin user or a holder, hodler, understands these technologies? What value does it add? There's a lot of technical stuff here, maybe not technical enough for the technical people, maybe too technical for the non-technical people. But if you have any questions, one, I have a handout link that'll be at the end of the presentation, which has a whole bunch of links to useful explanations of varying technical prowess. And then I'll be at the dinner tonight if you want to talk with me then. A little bit about myself. I contribute to Bitcoin Optech. We do, thank you. We do evangelism between some of the core developers and Bitcoin companies that use Bitcoin and try to facilitate communication there. We have a newsletter that you should subscribe to if you're technically minded, and we do some in-person workshops as well, where we try to build those relationships and roll out the technology. But I am not representing Optech for purposes of this presentation. Previously, I was a web developer before I fell down the Bitcoin rabbit hole a few years ago. And I love Bitcoin. I'm excited to be in the space. We all love Bitcoin. How could Bitcoin be better, right? You ask people at this conference, you may, well, price, right? Number go up, we talked about that, of course, but what other enhancements might make sense that could support this number go up hypothesis and support the price from a technical perspective? If you ask some people might say scalability. Another word for scalability could be efficiency in this scenario. So more on-chain capacity, cheaper transaction fees, and then maybe only paying for what you use. And what I mean by only paying for what you use is, this is a screenshot of blockstream.info block explorer, and the red box down there highlights the script that needs to be revealed in order to spend your Bitcoin. And you need to reveal that script regardless of if you execute part of that contract or part of that script or all of it. And so that can lead to either paying large fees to have a complicated script or just not wanting to use the script in general. And some examples of larger scripts where you could have many conditionals, you get a very prohibitive to spend output. So scaling is one improvement that we could talk about. Other people would say something like privacy. So because these scripts are visible, you can tell sort of what kind of output and what kind of transaction a certain spend is, and we'll get to that in the next slide. But that's not great for privacy. Additionally, the scripts themselves are visible. You can see what the logic is there. And then you can also see the participants, not in a meat space way, but if it's a multi-sig, you can see who the participants are. Also, you can tell that the number of signers, which could also give away certain information, as certain technologies use certain thresholds for signing. And we can see that in the next slide as well. So what we have today in Bitcoin is something like this. We have these very distinct balls or outputs or spends, however you want to think about it in this analogy. These scripts can reveal the nature of that transaction. So you have something like, well, there's a Lightning close transaction. I can see that right there. It's a very pronounced script that you can see on the chain that everybody can see. That's not great for privacy. Similarly, you can tell that something like BitGo or something like a green address wallet is transacting because they do 2 of 2 or 2 of 3. Likewise, it's the same thing applies to like a liquid peg out. If you're taking money out of the liquid network, you can tell because they have that federation that is 11 of 15. So you'll see some multi-sig that looks like that. It goes on and on, 3 of 5, single sig. or an atomic swap has a certain transaction structure as well. So some people think scalability is important, some think privacy important, and there's yet another group that thinks innovation is the most important thing. So things like, well, because these scripts are so expensive, people aren't using them. Because they're not private, people don't want to write these scripts and have their privacy out there, or leaking some privacy. There's a limited number of operations that you can do in a script, limiting the innovation that you can have in these smart contracts. It's hard to add new functionality. Bitcoin, is this immutable thing, right? So it's hard to add to. And then capping the number of multi-sig transactors. So you have scalability, privacy, or innovation. So where do you go, right? Which should we tackle first? Well, why not all three, right? And so BitMEX Research put out an article on Schnorr and Taproot recently, and this is a quote from the article. I'll just read it verbatim. In our view, the benefits associated with this soft fork are not likely to be controversial. This soft fork appears to be a win-win-win for capability, scalability, and privacy. And I think that's a good way to frame your mind about what's happening at a high level. It's maybe not a silver bullet for each one of these, but it's helping address each one of these. Okay, so great. So Schnorr and Taproot can help some of these problems, but like what exactly are these things and how can we use them as Bitcoin users? So let's start with Schnorr. So first we'll do the basics. We have signature and verification equations here where R is a random nonce chosen by the signer. I'm just kidding. Does anybody know what these equations are? I don't know what they are either, really. Maybe Jimmy can tell us next. So let's start with the real basics. So all Bitcoins are locked up in a lock that only the owner of the key can spend. But you don't just send your key out onto the network to spend your coins, right? Because somebody else could see that key and they could spend those coins then. So what you do is you prove ownership of the key by using a signature, and that's how you prove that you have the key in order to spend the funds to begin with. So these signatures kind of play a role in between the key and the lock, if you will, in this analogy. So to look at it visually, this is a bit crude visualization, and the technical people are rolling in their seats right now. But you have sort of this public key on one side that's like the lock, and then you have this key that can open it, and like the signature is the thing that connects the two. And so what we're doing when we're adding Schnorr signatures to Bitcoin is we're replacing that digital signature, which is currently ECDSA, with all we're doing is taking that and replacing it with a Schnorr signature. It's just a different type of signature. And replacing is probably not the right word because you can actually continue to use ECDSA if you'd like, so it's backward compatible. So we're just giving another option for signatures, if you will. Okay, so now we know a little bit about digital signatures. Let's talk about Schnorr signatures. In a oversimplified nutshell, Schnorr signatures are a way to stuff some additional data into a signature along with the signature itself. Again, oversimplified, but I think it gives you the idea that we can kind of put some things in there, and we'll talk about the interesting things that you can put in there. The first type of hidden data that you can put into a Schnorr signature is additional signatures. So let's say that we have a Bitcoin address that is a 2 of 2 with Alice and Bob, and in order for the funds to be spent, both of them have to sign off on the transaction. In Bitcoin's existing ECDSA, what you have is you have Alice signature, Bob's signature, and that equals Alice and Bob's signature. It's just really simple. Both sides are the same. But with Schnorr, you have Alice plus Bob equals Alice and Bob's signature. So the color here is to sort of help you understand that green encapsulates both the yellow and the blue, all in one signature without having to have two separate signatures. So some people may say, well, why would you ever choose ECDSA? Why not Schnorr from the get-go? And there has to do with some lack of ecosystem around Schnorr signatures related to a patent that was held for 20 years and expired right around the time Satoshi released Bitcoin, which stifled some of the innovation. Also, Satoshi used a certain library that I think had ECDSA built in. So what we're talking about here is key aggregation, and what that is you're combining multiple keys and signatures into one. And so the example that we saw, the 2 of 2, that becomes one signature. You could have a 50 of 50, and that's one signature. You could have a threshold signature, which is, let's say, I just picked some numbers here, 37 of 87. That could be one signature. And so to beat it into, here it is again. There's that arrow with the Schnorr signature. And you could have 3 different signatures embedded in there, Alice, Bob, and Charlie. But there's other things. There's other interesting properties of this Schnorr signature that unlock additional features as well. So the linearity property is what we just described, which is you can add these signatures together, and it can all be encapsulated in one signature. Call it magic. We saw that we just swapped out the signature algorithm in that animation. You can actually use existing private keys, private and public keys, with Schnorr, which is great because you don't have to have like this separate keychain for these whole new private and public keys that you would need to use. You can use the existing infrastructure to build on top of Schnorr, so we don't have to reinvent a lot of this stuff. Just a scaling space savings of 10%, which is obviously nice for scalability. The signatures are just 10% smaller. And then there's actually a formal security proof for Schnorr, whereas there's not one available for ECDSA, so that's nice. And then finally, it's just better. There's sort of like this category of things underneath there, like the signature can't be malleated, which helps with a variety of second layer protocols. It's simpler. There's a few other things there that I won't get into. Okay, so we have these ability to create these Schnorr signatures. How do we actually do it? Let's introduce another buzzword. So musig key aggregation. So we have our 3 keys, like the three of us that want to be in this multi-signature, and we want to be able to have this aggregated key. Well, I've glossed over how exactly that works, and we're not going to get too deep, but that technology, one available technology to do that is called musig, if you've heard of that. The Blockstream guys put out that paper, and it's a way to combine these keys into one. There are other proposed schemes for creating Schnorr multi-signatures, and people are working on others and iterating on this problem. One thing that's important to note is that the musig scheme, and I believe all the ones that are known, they require off-chain interactivity. So Alice and Bob and Charlie all have to sort of work together outside of the Bitcoin network to coordinate and get that key created and then signing as well. So it's an important consideration. Okay, so now we have this aggregated key. How do we sign? In ECDSA land, you'd have the 2 of 3 with the 3 pub keys that are part of the signing group, and then you'd have at least 2 of the signatures. So that's this 243 bytes, and when we cut that down and put that into transaction, when we cut it down into Schnorr, all of that just becomes one Schnorr signature. So you get rid of all that data. And anytime you're getting rid of data, one, it's going to be good for scalability, it's going to be good for your fee rate, and it's also going to be good for privacy, because if there's less data that you're putting on the chain, there's less data that anybody else can see. So great, we save a ton of space, fees, and privacy using, if we're using multi-sig. But what else does Schnorr enable? So in addition to be able to having these, like what I call like hidden signatures in there, Schnorr has the ability to also have like extra snippets of hidden data that can be embedded. I'm using like all kinds of analogies and improper terminology here, but I think you get the idea. It's not just a signature that can be loaded in there. You can have additional things, and one of these is called an adapter signature. And so I like to think of this like in my mental model as invisible ink. So you have the signature, so I'm sending coins and I'm signing per normal to move those coins. But along with that signature is sort of, if you have this decoder light, you can see that there's something else there. And that secret allows you to do some interesting things that nobody can detect except for the party that has this sort of light, your partner in this scenario. So by sending the coins, you're revealing some additional information. So what can we do with this, like this invisible ink? There's a few different things. One, it doesn't have to be cross-chain, but you can do atomic swaps. So for a maximalist group, that may not be appealing, but you could think of use cases where you're swapping coins within the Bitcoin network. You could do atomic swap between Bitcoin and Liquid and back. And so, or to other chains, of course, you could swap to an altcoin or any other chain just to trade. So atomic swap means if I'm sending you Bitcoin and you're sending me Litecoin, that both of those operations happen, or they don't happen at all. So there's no way for like me to send the coins and I don't get the other coins back. So it's pretty cool because you can actually have this atomic swap. You could theoretically atomic swap into the Liquid network, and it wouldn't, and then swap back, and it would be embedded in that signature, so that you wouldn't be revealing very much information at all. A second example is these coin swaps. So this is similar to a coin join, but there's like it's similar to Tumblebit. Like I think there's a central party there, but there's a tumbler without revealing like which coins are being swapped. So you can look into Tumblebit. I think I put this in the handout as well. There's some really crazy stuff. This is Andrew Polstra, like wizard level. The ability to, his example is, I could give you a proof that I have a solution to a Sudoku puzzle, but not give you the solution, but just prove to you that I have a solution in zero knowledge, and that when you send me the Bitcoin to pay for that Sudoku solution, the solution is revealed in that payment, which is like magic level. Like I don't know exactly how it works, but you should look into that because there's a lot of use cases there as well. But there's other data that we can put into a Schnorr signature as well. There's some interesting things on with payment channels that people are talking about being able to do with adapter signatures. So adapter signatures, I don't think I mentioned, but that's sort of like this, what I was calling like the hidden data is this adapter signature. And then there's other of these called scriptless scripts, and people are working on these ideas. A lot of the math people are working on these sorts of things. But what we want to talk about today is what else we could put in there is a script, and that's what Taproot is. So the simplified nutshell version of Taproot is it's the hiding of a script in a normal looking transaction using Schnorr signatures. So just like we were hiding these atomic swaps or these pieces of data, you can also you can also hide a script in there. And so that enables some interesting things we'll jump into. So there's no more spending to a key or spending to a script, because all addresses will be scripts and keys. You'll be able to the coins will be able to be spent one or either of those ways. And so I've heard this like termed pay to Taproot, P2TR. And so you could have the key in this scenario, since all addresses have this key and a script. The key could be a Schnorr signature, so it could be a 1 of 1, 2 of 2, whatever we talked about, 2 of 3. It could be a threshold, and you could spend using that construction, that aggregated key, if you will. But you can also spend using the script, and the script could be multiple scripts. They could be large scripts, and we'll get into the sort of metrics on that. And it's hidden unless you use it. So it's kind of like waiting there, and you can reveal like that there was a script after the fact, and then what path you took on that script. We'll get into some examples there. And so if you've heard of like SegWit version 0, like this is SegWit version 1. So this is like the next version of SegWit is the combination of these technologies, Taproot and TapScript. So let's look. There's a visualization of how this works. This is from a BitMEX blog post. It's also linked in the handout. It's a little hard to walk through, but there's let me see if I can get it. This is our Schnorr signature down here, our 2 of 2. This is sort of a combination of all the scripts that are part of our script. So this whole right side is like, you can think of it as the scripts, and then this is our 2 of 2, and those two combine into like what you could think of as our address. So our address is hiding behind it this set of scripts as well as this key where we can do our normal quote-unquote signing. And what this blue box around here is it's indicating that if you spend using the key, it's called a key path, if you spend using the keys, it looks like a normal transaction on the Bitcoin network. So it's just that one signature that we saw earlier, and nobody knows that you had the potential of all this magic behind the scenes. Okay, so what could we do with our hidden script? So this is an example, very basic, like this is just single signature. I have my bread wallet, and all it's doing is 1 of 1. I don't have to use a script if I don't want to. Second example, you could have a 2 of 2, and again, no script. But no one's going to know it's a multi-sig because we're just going to put that one transaction or that one signature on chain. Here's a more in-depth example. So what this is you could spend using the key path, which is a 2 of 3, with my bread wallet, my ledger, and Bitcoin Core. Or I can, what I'm calling like a fallback script, you could have a series of fallbacks. So I could immediately spend using a 2 of 2 with my backup Trezor, let's say, and then maybe a third-party service that does some 2FA that gives me a phone call to make sure that I want to actually sign. And that could be a way that I could recover funds. And then after 6 months, I could have my mom, a 2 of 3 with my mom, brother, and Bitstein to recover the funds. And then after 9 months, I could have something like my lawyer be able to recover the funds. So it's a little bit more in-depth example. And again, with the key spends, no one can tell that any of this is going on. But if we do want to spend on any of those scripts, we don't want to reveal the entirety of the script. So for example, let's say that I lose my ledger and my phone. So I'm unable to transact using the normal key path. I'm going to have to resort to going to find my Trezor, wherever that is, and getting my key from my third key provider, which is the first clause in this fallback script. I don't want that transaction, this broadcast, to say, hey, by the way, there's also a 6-month out with these public keys, and there's also a 9-month out with this lawyer guy. Obviously, they don't know the identities, but you get the idea. So how do we execute the script path without revealing any of the details to the public? And so this is the same slide. I've just kind of grayed out the script area that's not going to be revealed. So we're only going to have to reveal the path that we took, the script that we executed. So even when we're using the script path, we don't have to show everything. So you could potentially have hundreds of scripts, and then you can fall back to one of those, and that's the only thing that actually goes on chain. And you may have heard another buzzword called MAST. And MAST is the technology that allows you to sort of split up this script into a variety of different scripts and only reveal the one that you need. So obviously this is great for privacy because people don't know that I have like these backup clauses, and obviously I don't have to pay for these backup clauses that I don't use. I only pay for the one that I do use. A couple more examples using Taproot. So there's just this general category of exchanges in custody that makes sense. You can tell those are the examples I'm using, is these fallbacks and thresholds. There's telescoping multi-sig, which is either getting larger or smaller. So you could start off with like a 15 of 20, and then after a timeout, you could have a script that's like 10 of 13, and then that can go into like a 2 of 3 eventually after like a few more months for different business use cases. Additionally, there's this idea of a server honeypot that Blockstream wrote about a few years back, and I won't get into this example, but it's in the handout. And then puzzles. So this is like a small one, but I think there's this $1 million Bitcoin game where there's all these pieces. I think it's Schmier's secret sharing hidden all over the world, and people are trying to get a certain number of these pieces together so that they can claim the $1 million. And so something like that could also be done using something like Schnorr signatures as well, and you collect the signatures. So we talked about we wanted these benefits, right? So scalability benefits. So if you're using multi-sig, it depends on the use case, but something like 30 to 75% savings for large multi-sigs. And what's interesting about this, and I think I think this is going to have some interesting implications. Is multi-sig doesn't cost anything additional in these scenarios. So why would you not be using multi-sig, right? So I think there's going to be a proliferation of multi-sig usage in the coming years, assuming these upgrades get rolled out and adopted and consensus and all that. So I think you should be keeping that sort of thing in mind if you're an individual or if you're a business as well. And not only are there going to be, I think, more usage of multi-sig, I think there's going to be more parties to the multi-sig. So if you think about it, if you're doing custody, like you might want to only do a 2 of 3, not because that's the best business case, but because you don't want to spend the money for an 11 of 15, because that's going to be more expensive to transact with. So the fact that you can now transact with these bigger multi-sig parties, I think is going to result in people who are using multi-sig maybe using additional people to the party. We talked about only partial scripts get revealed, only what you pay for what you reveal for what you use. And so obviously there's a savings there. And then in the future, this is not something that's coming soon, but you could do batch verification on aggregated Schnorr signatures. And if you had a block full of, let's say, all Schnorr signatures, the example would be it's like a 2.5 times speed up. So if you want to run a full node, or if you think that's important, the batch verification would be a huge win there. On the privacy front, all outputs are indistinguishable. We talked about that. The cooperative key spend, it's called cooperative in some cases, but the key spend path transactions are also indistinguishable. So as long as you spend using that key, or that threshold, people can't tell that you have a multi-sig behind it, and everything's going to look the same. And you're not revealing that you're using multi-sig, you're not revealing the participants, all those negative things that we talked about before. And then the fallback script, if you do need it, you're only revealing a piece of it. So obviously that's huge. These are all huge privacy things. On the innovation front, obviously the larger multi-sigs are possible. The limit is something like 4 billion scripts. So I showed like 3 or whatever that was. So with that limit, there's a lot of like interesting things that we could think about doing with that space. SegWit v1, which is this Taproot tap script, introduces a versioning field to Taproot itself, and which enables like 256 versions of TapScript. So you could introduce different features within each version of that. So that's interesting because some people ask, like, aren't there only like 16 or 17 SegWit versions? Well, there's that, but you could have these notion of these subversions as well. Mast is just the first version of that. And there's some small script changes to the normal Bitcoin script using TapScript, but I don't think it's anything notable for this presentation. And there could be additional innovation around musig and the way that these keys are created, so that it's not maybe so intensive in terms of coordinating individuals going through these like 3 rounds of feedback to generate these keys. So we started with those balls that were all different colors, and it was kind of clear who was doing what. Well, we could sort of end up in this scenario where we can no longer easily distinguish coins and spends. So you get this pay to Taproot kind of appearing everywhere as people start adopting the technology. And it's a little bit, maybe everything looking exactly the same is strong to say, but it's a little bit more homogeneous and a little bit more private in that way. So I'd like to go into a little bit about like how Schnorr and Taproot fit into the larger Bitcoin ecosystem. So you don't want to write these Taproot scripts by hand, even if the words that I can read on these slides is fairly simple, like after 2 months, my mom and my brother can sign or whatever, that's like not really easy to write in Bitcoin script. And so there's this thing called miniscript that's being worked on, and script descriptors kind of fit into some of this, where it allows you to write these policies at like sort of a higher level, and so you don't have to write all this necessary lower level code. So that's something that's being worked on. I think it'll be interesting here. As I stated, my own personal theory is that multi-sig is going to be everywhere. I think everyone's going to use it. There's not going to be a really good reason not to use it. And so this technology called partially signed Bitcoin transaction is the format in which you can pass around a transaction. Let's say I'm the first signer. So I sign, and I need to pass to the second party so that they sign. The format that you pass that around with and how you pass that around, those sorts of things are going to innovate in the coming years and be really interesting. And PSBT is a part of that, the data format, and not necessarily how you pass it around, but what you're passing around. So coin join, incentivized coin join. So right now we talked about that for a given input that you could have this signature aggregation or combining of signatures. Now you can't combine everything into one, like one transaction is not going to have one signature yet. That's something that the developers are working on. And at the time that they have this, what's called cross input aggregation, so that one transaction can have one signature regardless of the number of inputs. What you have there is you have this incentivized reason to coin join, because if you only need one signature and you can have potentially 100 participants, 100 inputs and 100 outputs and only one signature, that is cheaper to be a part of that group and get the economies of scale there than it is to just send a regular transaction, one input, one output transaction yourself. So that incentivizes people to do coin joins, right? And you won't be doing it necessarily overtly for privacy reasons. You'll be doing it for space savings. So I think that's another thing to keep an eye on as well. And there's some interesting things around Lightning and channel factories and being able to onboard a lot of people in a single transaction and things like that. But these are kind of like a little bit more in the future, and quite frankly, I don't think they're baked enough. So what is Schnorr and Taproot not? So it's not these things called Graphroot or Garroot. If you've heard these other terms, those are things that developers are working on for subsequent either TapScript versions or SegWit versions. And they're cool. You should look into those. There's another soft fork that's proposed called SigHash no input. It's not that. There's another soft fork called the Great Consensus Cleanup that fixes some edge case bugs in Bitcoin, and this is not that. People talk about quantum resistance. This is not that. We talked about having one signature for a transaction. Not yet. Maybe in the future. And people have talked about like one signature for the entire block, and this is not that either. At least not in its current state. Okay, so when do we get this next version of Bitcoin? So Bitcoin upgrades. I'm running a little bit short on time, so I'll go quick here. It's like, how does the Bitcoin? I thought this thing was immutable, so I thought this is like a mountain. How we can have these upgrades? How does that work? So just a quick overview of how these things might get rolled out, or usually get rolled out. There's some innovation, some idea that somebody has that they've thought of, and they're discussing it with their on the mailing list or the chat rooms. That leads to this Bitcoin improvement proposal, a BIP they're called, and that's a formalization of the idea, and that rolls into getting feedback from the community, and that rolls into eventually getting enough feedback that you can create an implementation. Eventually, it needs to activate in some way on the network, so we need to coordinate everybody or some percentage of the community to activate and say, yes, we do want this thing. And then eventually services like wallets and exchanges adopt that particular technology. So where's Schnorr and Taproot? Collecting feedback still. So I do believe there's some work on implementation, but it's not something that it's like the implementation is ready and going to happen. Although I think from what I'm gathering, there's not a lot of negative feedback about this, so perhaps it won't be too contentious. A couple more little tidbits about the upgrade. It's only 500 lines of consensus code, which I'm not a core developer, but I've been told is not a large amount of code to review in terms of consensus code, although that's always something you want to be safe about. It's going to be an easier technical upgrade for ecosystem partners like wallets and exchanges and anybody who's interacting with Bitcoin to adopt, because it's simply just flipping the SegWit version up. And there's some other things going on there, of course. But like SegWit, introducing SegWit was a bigger jarring change for community. So don't expect it to take too long to be adopted. It's completely opt-in. So if you don't like any of this, what I'm saying today, you don't have to even know it exists or use it ever, which is awesome. And you broke it. That rolls into the fact that it's backward compatible, and we can I have a little slide on forks I'll go through quickly because it's meat related, and this is a carnivore audience. So you can think of consensus like the set of rules that run Bitcoin today, and that's, let's say you're following a carnivore diet. If you're doing a soft fork in this analogy, you're restricting the rules, and that is like eating only ribeyes. That's like a soft fork of carnivore. And if you're going to do a hard fork of carnivore, that's going to be like going from eating only meat to also eating like plants, so it'd be going omnivore. So you're changing the rules of the game. And so I'm not talking about chain splits or anything like that. This is just the way that changes can be rolled into Bitcoin. So you don't want to have a hard fork because it's not backwards compatible, essentially. All right, so when are we going to get it? Nobody knows. How hard will it be to activate? Nobody knows. What activation mechanism is it going to use? I don't think anybody's proposed an activation mechanism for these changes yet, meaning that's how people vote on it, if you will, or signal for it or whatnot. Okay, what can you do? Well, you can learn. You can review the handout and some of the links on there if you're interested in this topic. You can subscribe to the Bitcoin OpTech newsletter. We provide updates when available related to the mailing list or any discussions that are happening in the developer channels. You can explore use cases on your own and share that with the community. I tried to share a few today. And then you can encourage adoption from your ecosystem partners, whether that's the wallet that you use or the exchange that you use to adopt these sorts of technologies so that you can use them yourself. Thank you.